address space and the IP address of that DHCP server. So I know we're gonna have a test tomorrow. So do you have any question about DHCP version 4 first before we move further? Yes, no, no, yes.
No, sir.
No, sir.
Okay. Now on the IPv6 configuration, it's the same concept. I think we have, I configured this one with IPv6. Let's see. Exit, exit one more time. Show run. See, no, it doesn't show that. Yeah, this one has the old one with IPv6, IPv4. See that? We did that. Yeah, didn't work with that. Okay, so now we get some issue yesterday on configure a DHCP v6, DHCP v6 server. So what happened if we connect this guy with a multiple PC? Let's see. Hmm. So now we need to connect it to the same switch right here. Doesn't matter at this point what ports I can connect into. I just want to see if it works as a DHCP server. And again, um, if I'm doing it this way, what kind of DHCP server I'm creating? I'm creating basically when there's no router involved. Basically, it's going to be stateful. That means every options, everything's handled by the server, and that's basically um, what's going to happen. So, in order to do this, now also, if you want, you can connect this one to a router. Okay, so no big deal. So you will have a partial configuration on this server here. It's like a stateless if you want to connect stateless, and the router will handle the rest. So if you want to do that, you have to click on this machine. You need to give it an IP address with IPv6, which is already did. If you go to desktop, I gave her this number. Let me write it down because I can forget. Um, so this is going to be 200 or 2000 colon face cafe. Came up with those names, so it'll be a lot easier. Plus 64. Okay. So the first thing I need to do, I need to go to services. I click on a DHCP6 and need to put that server in there. Then I need to create a pool. Okay. And I need to give it a name for that pool. So I'm going to call that, uh, what would you call it? IP TV6. I'm going to call it pool. And I need to put, for example, the DNS name, which is, I can put the IP address for the DNS like 2000 colon space colon cafe double colon and I call the server is 10. I can make it like 9, and also I can put the domain name uh, about stp.com. I just came up with that. And now you need to put um, at this point is stateless. Basically, I'm going to provide everything will be on the router except with the DNS is pointed to that server. So if you go next, what's going to happen? Okay. Then over here, if I want to use, I need to create another pool right here to go to stateful instead of stateless. Okay, so I can do that too. Let's see. Let's see. We go right here, and when you do the IPv6 local pool, so I need to create a local pool, I guess. Yeah, the IPv6. Let me go create the local pool first. Let's see, create a local pool. No, I need to create this one first. Okay, this is 200 IPv6. Um, we call it the 2000, I believe. And this is like a prefix 64. 64. I'm not sure which one we need to do first, this one or the other one. Let's see. I'm looking for some documentation. So, enter this one. Okay, that's fine. You go straight for DSP. You go to yeah. I need to go to local pool. Let's see if I can save this one. Nope. Let's see if it's input. Local pool. Yeah, so I have to do local pool first. That's in the local pool. Okay, so local pool is gonna be IPv6 and the prefix is 2000, I believe, colon, and the prefix 64. Of course, here is the 64 also, and you save it. Okay. Now we go over here and create it. Okay. Go to see why this is a prefix is what's the prefix on that? Well, is it 200, 2000, colon, trace, colon, CAFE, colon, 64, the name, IPv6, Why cannot be empty? Which one? Oh, the identifier, unique identifier. Uh, let's see, what are we supposed to do on the why? Let's see, where's the unique identifier? What we're supposed to do? Say, what's the GUI? Let me see how I did that on the other one. Let's see. Edit. 1064 save. Okay. Let me see if that's gonna work first before I go any further. So if we go to desktop and you go to DHCP, yeah, it's not working. Let's see. Static. Oh, I did that. Let's see. I think I did one of the server right here. Uh, one more time. So you go to this one here. We did this one. Valid 25. Local pool. Um, can we edit the first one? Okay, so this is DNS. This is the local one. Edit. Save. And this one, what's the problem with this one here? Fix, create. IPv6. Local pool, let's see. IPv6. Can I say it was saved in here? Yeah, that's it. Okay, now let's see this. We're gonna be working in here. Hmm. I don't know why it's not. Yeah, now it's working. Now it's working. I guess it takes time to send the unicast back to it. Uh, now it's working here. So now you can see if it's pinging or not. So we can go to, let's see, this guy here, and you go to command prompt, and you can do IPv6, IPv6 config config/all. What? Oh, IPv6. One word. Config/all. Oh, we go. So as you can see, you have the global unicast address and you have the link local address. So this is the link local address right here. And this is the global unicast address. Notice you have the 686C on both of them. So what that means is they, if you look at the MAC address, okay, that's the MAC address right here. So it's part of the address is the MAC address. See that? So the FEAA, even this part right here is part of, you see that FFE right here, FFE, that's basically part of the MAC address inserted there. So you can see this one. which is part of the MAC address. Anyway, so can we ping this guy from the server? And that's what we need to test. Copy, and we need to go to different address, different machine, right here. Command, right click, paste. It's good to put ping in there. Not in there. In the front of it, so ping, P-I-N-G, enter. Okay, so it looks like it's working. So that's the stateful, that's a stateful configuration. Okay, so everything's handled by that server. Any question about this server? No questions? Any question about the test tomorrow? So for the test tomorrow, you're gonna have. Let me see. Well, I forgot to send an invite for one student. Let's see. I don't understand that. Why we have to do that every day? Emails. So any question about the written part or the online test for tomorrow? Participant or invite. Okay. Any question about the test? No?
Not really.
Okay. So if you don't have a question about DHCP, we can start a new chapter, which is, let's see. Let's see which one we need to start. Chapter PowerPoint. Chapter what? Which one is that? 8? Is it 8? Oh, that's chapter 8. Chapter 9. Chapter 9. By the way, I uploaded the PowerPoints on the files folder. And also, I uploaded some of the server one PowerPoint to the files folder too. So, so you should see
Thank
them
you,
in
sir.
there. Any question?
No, sir.
Questions? Okay. Um, First hop redundancy protocol. This is a new technology basically because we create redundancy on the different layer. We create redundancy on physical layer by adding extra cable or extra leg. We create redundancy on layer 2 with the span tree protocol. But the question is, doesn't matter how much on each layer you create with redundancy, but what happened if the router 3 fail? Because at the end of the day, you have a router, and the router is a single point of failure. So what is going to happen in this regard? So if you go to packet tracer, basically what I'm talking about is um, let's see, maybe we can take this one out. Boom, 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 boom. Okay. Um, so what happened if this guys go down? Okay. So basically, let's connected to one leg. So let's say this is the ISP right here. It's connected to the cloud. Let's see, make this one as a cloud. Go turn it off. Let's add the serial interface to it. Put it back on. Same thing on this guy here. Turn it off. Oh, this one has serial interface, so that's cool. So we can create link in here. I guess it's still down, huh?
On the first router.
Oh, put it in there. Okay, now. So we connected with serial to serial. Okay. So it doesn't matter how many hosts we have on this LAN here. So the ideal situation is saying, what happened if this one goes down? Somebody said, okay, we create another router. We just put another router in there. Okay. So what's wrong with that picture? Let's see. So if, for example, I have another link right here from this switch to this router. Okay, so if this is going to solve the problem, if I put another router, what's wrong with that picture? So every machine over here is going to be configured with what? With a default gateway. So that's basically the case. So you have, for example, 20.1, that's the interface for this. So even if I have a multi-router over here, another router, so if this failed, I'm gonna go back to each device and change the what? The default gateway on it, which is a lot of work. Okay. So that's why they came up with they call it um, the FHR. It used to be a different name, but now they have it FHRPs, which is hop redundancy protocol. Okay, to able to create what we call something called a virtual router or virtual IP used to call it. Okay. And that's what is the first hop redundancy protocol are a mechanism that provide alternate default gateways in a switch network where two or more routers are connected to the same VLANs. And we need to see how that works. Now, even if we create if we have another router over here, right? And somebody said, okay, I can come to this machine, each machine, um, whatever, and change the default gateway in it. So even if you change, sometimes it's not going to work as fast as possible because what is also associated with that one? You remember we talked about ARP, the MAC address table? Because whenever this guy wants to communicate to the cloud, okay, so it's going to send ARP request to this default gateway, which is he wants the MAC address for this. The MAC address is going to be stored in the ARP table for a certain period of time. So even if I change the address, the gateway address still is on the MAC address table. So that's another problem. So to resolve all this, okay, that's why they came up with the first hop redundancy protocol, the HRP, okay? And the way it's going to work is to create what we call a virtual IP or a virtual router. Also, we're going to provide the client with virtual MAC address. So, so the client is going to always, regardless, is going to have a virtual IP and a virtual MAC address associated with that. So what does that mean? Means this. So at this point, this router here, router one and router two, each one of them is gonna have an IP address. Let's say that one, and this one's gonna have that two or whatever address. Now, or I can have dot two here, dot three here, or whatever. Doesn't matter. Now, I'm gonna create another virtual router here, which is VIP or virtual router or virtual address. And also, I'm going to have virtual MAC address. Okay, so with the virtual router, what IP address I'm going to assign? Maybe I can put dot 254 or dot 3. Doesn't matter. So whenever I'm going to use this kind of technology, I'm going to assign these machines with the route with the right gateway. So I'm going to assign it, for example, 192.168.10.3. No, not dot 3. This is dot, let's say, 10. With the gateway is going to be 192.168.10.3. Well, somebody said that dot 3, this router is dot 1, this is router dot 2. Where's the dot 3's came from? That's what the virtual router. So regardless if this link goes down or this link goes down, always I'll be connected to the cloud. Okay. Of course, they have a mechanism or a process we have to follow to understand in order to change because one of these routers, one of these routers has to act as a boss. Okay. And he's in charge. So that's why we call them. One is going to be active, one is going to be what? Passive. One is going to be active, one is going to be on standby. And that's basically how it works. Now, the question who's going to be active, who's going to be passive, we have to follow certain rules. And we're going to talk about it in a few seconds. This is they talk about the old what we talked about earlier on semester one. For example, one way to prevent a single point of failure at default gateway is to implement virtual router. To implement this type of router redundancy, multiple routers are configured to work together to present the illusion of a single router to the host on the LAN by sharing an IP address and a MAC address. Two or more router can act as a single virtual router. So it's not just one. I can put more than a virtual, a physical router. So that's what we call in a group. We can put up to, I think, with the new technology, we can put up to from, I think, 1024 routers to be in redundancy and load balancing. On the old version, we used to put 255. Now they enhance it to 1024. Can you imagine you can put like 1024 redundancy in layer 3? That's a lot. And usually, if you want to do this kind of technology, you're not gonna mismatch those routers. You can put like Cisco or whatever, but it doesn't matter because this is standard, so you can implement that technology. So there's a correlation between um, if I said, okay, I'm going to create virtual P, but somebody said, okay, how about the MAC address? Because we always associated, because whenever you whenever this guy recognizes that the destination is on a different LAN or a different subnet, he's gonna request the MAC address for the gateway. So that's why we always also need to work with the virtual MAC address. So anytime we have a default gateway, we need also the default MAC address or the MAC address for that default gateway. Let's see. So redundancy protocol provide a mechanism for determine which router should take the active role in forwarding traffic. It's also determined when the forwarding role must be taken over by a standby router. The transition from one forwarding router to another is transparent to the end devices. So the ability for a network dynamically recover from failure of device acting as default gateway, known as the first hop redundancy. So what does that mean? Means means I have more than two routers to create a redundancy. And we know each router's connected to the same LAN. Well, the way you connected to the LAN with the interface, that means this interface and this interface are on the same network as this guy, as the client. So, because I'm not going to change every second the default gateway on this one, I'm going to assign the gateway for all these devices, end devices, with the same, with the virtual IP, which is, for example, if this network, what network is this? Let's see, 50, 20. I made a boo-boo. So this is dot 20, not 10. Yeah, 20. Same thing. Yeah. So now this is virtual. This is the virtual router. But if, for example, I'm on PC 7 and I'm trying to connect to the cloud, which path I'm going to take to the cloud? Of course, over here you might have another connection to the cloud right here. Okay. So, or I'm going to go this way, or I'm going to go this way. So, how are we going to determine that? And to determine that, are we going this way? Or I'm going to go that way. Okay. So, how are we going to make the decision? To make a decision, if I am using this technology right here, the first hop, the, the first hop redundancy protocol. So I want to make decision if I'm going that way. If I'm going that way means this guy's in charge. If I'm going this way means this guy in charge. So how we know which one is going to be in charge? Now, from user perspective, he care less which one is going to be active, which one is going to be standby. Or all what this guy care about is to have continuous connection to the cloud, to the internet. So, and that's why we have to go through the process. As you can see over here, we need to configure each router, the physical router, not the virtual, because we have the virtual router right here. This is virtual, y'all. It's not really a physical connection, okay? It's just virtual. Assume, believe this is a router over here. But in reality and physically, there's no router in here. It's a virtual router. So we're gonna configure this router by something called standby, and this one standby. So one of these router here and here, basically the physical router, need to be active, one is going to be standby. So the one is going to be active. Basically, once we configure the standby on both of them, the standby is going to decide which router is going to be the active and which one is going to be the standby. So both routers by default, they have something called priority. So whenever they exchange standby message, they exchange the priority. By default, the priority is 100. So if both routers by default is 100, so at this time we cannot decide which one is going to be active, which one is going to be standby. Now, to break the tie, we're going to say, okay, the router with the highest IP address is going to be the active one, and the one with lowest IP address is going to be the standby. So, according to this, what I'm saying, this is has dot one, this is has dot two. Both router has the same priority. Therefore, this is going to win because it has the highest IP address. So in this case, this is going to be the active one, and this is going to be the standby. Now, the minute this guy goes down or this link goes down, automatically the user is going to go through this router right here. You follow the idea? Any question about this particular topic? So that's the big picture. Of course, there's a lot of details we need to discuss. What do you think? Uh, question at this point?
No, sir.
All right. And that's the rule right here. Need to enable the what we call hot stand router HSRP, which is this is the Cisco protocol. It's developed by Cisco a long time ago. So HSRP is used a group of router for selecting active. Okay, so we have different version of HSRP. We have version 1 and version 2. Version 1 support from up to 255 routers to be on to participate in the group. On version 2, we have 1024. Okay. Uh, of course, you have virtual router redundancy protocol version 2, which is this is non-proprietary election protocol that dynamically assign responsibility. So there's not Cisco issues here. So we have a different standard. Now, Cisco came up with this, we call Gateway Load Balancing Protocol, which is GLBP. There's a lot of different names, and I cannot say them fast enough. When you say FHRP, HSRP, VRRP, GLBP, that's a lot of different acronyms, okay? And Cisco, they came up with this idea. He said, okay, since we have two links and we have two gateways, why we need to put one in standby? Why we cannot make it open and forward traffic to it if we can? And that's why they created the gateway load balancing protocol, so we can send traffic both ways. But still, we're gonna have one router in charge, one router the boss. Okay, so the first packet, the router receive. Okay, the second packet is gonna go tell them, okay, go the other way. So one goes this way, one goes the other way. One packet goes this way, one packet goes the other way. Now, if one of the router goes down, then one router will take the responsibility and forward all the packets in one way. So that's the idea of GLBP, okay, which is made by Cisco. It's the same idea like an STP. Remember in the STP, we have one link is blocked. So Cisco said, okay, since we have a link in there, why we cannot use it for different VLANs? And probably the same concept over here they did with the GLPP. Um, so that's the HSRP, and that's what we need to configure your router with that. Okay, so that's the idea. Now, we already talked about active router and standby router, and also because this one has the highest address and this one has the lowest address. So somebody said, well, I want to make router one to be the active one all the time. Okay. Can I do that? The answer is yes. How you do that? Well, I increase the priority. So if I increase the highest, the router has the highest priority, that's the router is going to be the active one. You notice here we have priority 150. Over here we have the priority 100, which is the default one. So therefore, if I configure it that way, so this is going to be the active one. Now, question: What gateway or what is the default gateway address for all these clients right here? If this is the active router, this is the standby router, and this is the virtual router. So what is the gateway address, or what should I put as a gateway for all these machines right here? Somebody give me the
The
address.
virtual,
So we have to put correct the virtual. It's going to be 172.16.10.1, not 2, not 3. Dot 1, because that's the virtual IP address. Okay. And also the virtual IP address is associated with this MAC address. And you can tell from this octet here, 0707, not octet, this is hextet, OC07. And I can tell they still using version 1 from this address right here. Now, if you're using version 2, you can see 09 instead of 07. That's how I see between them. Or the difference between version 1 and version 2. So this is what they're talking about here. To configure the router to be active router, use the standby priority interface command, and the range of the HSP priority is 0 to 255. Now, if we put 0, if you put the priority 0, that means that router will never be an active router. It's always going to be on standby. Okay. Any other questions? Now, they mentioned something called preempt. What does that mean? A preempt is a configuration. You do it on this one here. For example, you say, well, and most of the time, especially in here, if you have, for example, a PCA, the PCA is connected to this router, or your home, for example. You'll never know. As long as you have a link over here from here to the gateway, you're okay. You're not going to tell if you have access to the internet or not. Now, what happens if this link goes down, or this, or any of the interfaces? So that's why you configure something we'll call preempt. Preempt means is like a trigger. So basically, you configure and say, well, if something happened to this interface, I need to know. That's how you configure the preemption. You trigger some kind of election, who's going to be the active, who's going to be the passive. And the way it works, if goes down or goes down, the priority value is going to decrement by whatever value you put. By default, I think on the packet tracer is decremented by 10. So you're going to subtract from 150 a 10. Then if this is down or this is down, it's going to be, this value is going to be 140 instead of 150. So always whenever you configure the priority, don't make it high like this 150, especially on the lab, because if you decrement by 10, still this has highest priority. Still this is going to be elected as an active one. So you put, for example, 105 on this one here. So if this link goes down, you decrement it by 10, then this is 95, this is 100. So therefore we go that way. You get the idea? So, I mean, tomorrow after the test, which is Monday, we're going to do some configuration on this one. So you'll be okay. So with the preemption disabled, the router that boots up first will become the active router if there are no other routers online during the election process, which is true. So everybody think is the active router before you configure it. Once you configure it, then they exchange information between the two. And say, oh, you have the highest priority, then you will be this is going to be active on, this is going to be standby. Okay, so if you don't have a question, I'm going to stop at this point. And for the test tomorrow, as usual, you're going to have some kind of hands-on. You're going to create DHCP server for 2 LANs. And also you're gonna configure a router work as a DHCP server for different LAN, and you need to make the 2 LANs talk to each other. Okay. Any question at this point? And the test start at 9:25. And as usual, I upload the topology for the skill test on the files folder. And also, whenever you do a packet tracer, you need to put your name on the profile, like we talked about before. I don't have to repeat it every time. So when you go over here, and instead of put guest, you put your name, you put your email, and you say okay.